Hey guys, today's lesson is going to be on graphing quadratic functions. The student learning objectives for today are to define parabolas, identify parts of a parabola, and then use equations to find the values for those parts of the parabola. So this is more specific about quadratics. We've already talked about graphing polynomials. This is more specific for quadratic polynomials. Essential questions: what is a parabola, what is a vertex and axis of symmetry, and what are zeros exactly. And below we see the common core standard. The graph of a function is called a parabola. Parabolas have two things we're going to talk about today about parabolas. They have what's called an axis of symmetry. It's this straight line that goes through the center of the parabola. It's vertical. So a vertical straight line that goes through the center of the parabola. This point right here is called the vertex. It is either going to be the lowest or the highest point of the parabola, depending on which way it opens, but it is at the center of the parabola. So that's important to know. And because it is also at the center, the axis of symmetry runs through the vertex. So, like I said, the parabola can either open up or down. The turning point of the graph, either the lowest or the highest point, is known as the vertex. That's this right here. So the lowest point, if it's opening up, see how this kind of looks like a valley here? If it's opening up, it's going to have a lowest point, and that's going to be the vertex at the center. If it's opening down, see how this kind of looks like a mountain? It's going to have a highest point up here, and that's going to be its vertex. It will be the maximum. And last thing about the parabola, it is symmetrical. So this axis of symmetry is actually the line in which it's symmetrical about. So it's reflected about this line. So this side, this right side of the parabola, it's going to be mirrored exactly on the left side of the parabola. So we have our standard form of a quadratic function is ax squared plus bx plus c equals 0. We're going to use this to, you guys may know this already, but we're going to use this to find the parts of a parabola, like a vertex, the axis of symmetry, and zeros, using different formulas. The standard form of a quadratic function, again here it is ax squared plus bx plus c equals 0. The x value for the vertex of the parabola can be found using this equation. X equals negative b over 2a. That negative b comes from the standard form, and the a comes from the standard form as well. That's going to give you just the x value of the vertex. In order to find the y value, we need to take that x value and put it back into the original equation, solving for the y value. Once we have those, we have to remember the vertex. So if we're asked to find the vertex, it needs to be in an ordered pair of x and y. So I'm going to put my x value here and the y value I find here, and that would be my answer. So x equals negative b over 2a is a very important equation, not only because it helps us find the x value of the vertex, but it also gives us the equation of the axis of symmetry. So any equation in the form y equals something, that's going to be a horizontal line, because the y value never changes. It stays the same height, if you think of it that way. And in the same respect, the opposite way, any vertical line is in the form of x equals, because it never moves left to right. All the points are above each other. So it has the same x value. All the points have the same x value. So the equation for a vertical line is in the form of x equals something. Well, since we know that the vertex is on the axis of symmetry, and the axis of symmetry goes through the vertex, we can use x equals negative b over 2a to give us the equation of the axis of symmetry. And last but not least, quadratic functions have two zeros. Now, I wrote this Usually quadratic functions have 2 zeros. However, there are occasions where they may only have one, which is if the zero lies, if the vertex, lies on the x-axis. So if the vertex is the zero, it will only have one, as in this example right here. Or if it is opening up and the vertex is above the x-axis, it will never intersect with the x-axis, so there will be no zeros. And in the same respect, if it's opening down and is below the x-axis, it will also never intersect, so there will be no zeros. So just a reminder that zeros are also where the parabola intersects the x-axis, so we can also call them x-intercepts. The value there is y equals 0. Y will always equal 0. We do this, we find zeros by setting the standard form of a quadratic equation equal to 0. Because again, if we have y equals ax squared plus bx plus c, we need to set that y equal to 0 to find 0. And when we do that, we can use the quadratic formula to find the x value here. And because y is always 0, we know that the y value is 0. So again, the x-intercepts are points on the parabola, so we need to express them as an ordered pair with x and y. So whenever we find our x value using the quadratic formula, put that guy right there, and the y value is 0. And that's all I have for this lesson. I hope you enjoyed yourselves. Remember to go back through the video to review anything that you didn't fully understand. Make sure you take good notes. Try the homework assignment. If you have any questions, feel free to contact me via BBIM, email, text, phone, whatever's easier for you. And make sure you come to live class so that we can go over this more and go through some more examples.